They're not as fit as you.
All right, I'm recording now. I am currently recording.
Sorry.
All right, ideas. What should we do first on this proof?
Straight line down the middle.
The left side.
Tangent of 2x.
Tangent of 2x, fix the left side. We're going to work on the left side. All right, so tangent of 2x. Look at my unit circle, and it says this side is going to look like this now. All right.
And then we can change both sides to cosecant squared. One, or tangent squared minus 1.
Oh, 1 minus tangent squared is cosecant? No, it isn't.
Maybe it's not.
Nope. It says 1 plus tangent squared is secant. 1 minus tangent squared is nothing.
I mean, if you wanted
I don't.
What?
I don't.
Yeah, I know. Okay.
Although I will say that, I mean, maybe we could change the other side. Because the other side says cosecant squared, and it's 1 plus cotangent squared, so at least that would get us a cotangent on this side. Or we could split it to x's and y's. Anybody have some ideas that they'd prefer? Should we try x's and y's? All right.
Sure.
Did anybody get this right? Cool. What did you do?
For what? I didn't switch it into x's and y's. I did 2 cotangent times the reciprocal of 2 tan over 1 minus tangent.
Okay, so let's start there. 2 cotangent x over 1 times 1 minus tangent squared x over 2 tangent x. So basically, all we've done so far is just change this big dividing into a times and flip the second one. I definitely think we should take out those 2's. Can you cross out just the x's on the top and the bottom?
Yeah.
No. This is cotangent of x and tangent of x. That means that, like, it's referring to the angle x. This is important, Kyle, because every time you write this, you always write cotangent and tangent, and you don't even write the x in there, and then you get confused. Okay? So, Kyle, you're wicked smart. Super smart. So smart. But if you keep taking shortcuts like that, you're just going to get these problems, like, 100% wrong. So, don't just do it because it's like, ooh, I don't want to write down the x. Yeah?
Dumb question.
It's not dumb. Go ahead.
What did you say?
I said it's not dumb to ask a question.
Oh, I thought you said shut up. I'm like, oh, okay.
Thanks for at least asking what I said, because you were like, that seems like probably she didn't say that.
Yeah. No,
Good call.
So,
Don't usually tell kids to shut up, except for when I'm like, shut up, because somebody's like, I've got a ferret.
yeah.
And I'll be like, what?
Okay, so like, you can't take out the ones because the 1 is connected to the tangent.
Right.
Right, okay. That was my dumb question.
That's not dumb. All right, let's,
But then why can you take out the 2's if you can't take out the 1?
because this is 2 times, and that's 1 minus. So if there's a plus or a minus, it's like attached to the other thing, but times stuff, you can cancel out anything you want. Okay, so I'm going to change the top into x's and y's. I'm going to be very careful about it. This is x over y times 1 minus y squared over x squared. Does everybody understand that tangent squared can be y squared over x squared?
Yeah.
Divided by y over x. All right, now if I distribute this to both of them, I end up with x over y minus x y squared and y x squared. And then I'll write times x over y. That's this one just flipped. All right, let's see. If I clean this side up a little bit, I can take an x out of here and an x out of the bottom. You can take a y out of here and a y out of the bottom. Do you guys recognize that even though it's behind it, I could still distribute this in here?
Yeah.
Okay, so then I end up with x squared over y squared minus xy over xy. Yep. We're trying to get to cosecant squared x minus 2.
Well, 1 plus cotangent equals cosine. Oh,
That's
minus.
true. Great point. All right. So, do you remember how up here, great point, Kyle, that cosecant squared x. So now here's the point where I'm at, and here's how I would figure this out. I'm just going to copy that down to like about here. Okay, so I'm right about here. And I think, okay, so on this side I've got cotangent. This side I've got cosecant. But I know that cosecant squared is the same thing as 1 plus cotangent squared. So I'm going to rewrite this cosecant squared as 1 plus cotangent squared x minus 2. Where'd that minus 2 come from? Yeah, it was right here. And 1 minus 2 is negative 1. Did you, how did you do this without x's and y's?
Well, so right when you have cotangent minus cotangent times tan squared all
Yep.
over tangent,
Yep,
you can cross out tangent.
on the bottom and the cotangent on the top? No.
Then you have cotangent over tangent minus cotangent times tangent.
Yeah, I see what you're saying. And that would work too. I would totally give you 100% for that.
Wait, so cotangent over tangent doesn't X out?
No, tangent over tangent,
Oh,
x
I
out.
did that. I crossed it out. I crossed out 2 times x over y divided by 2 y over x. And then I was left with a 1 minus y squared over x squared. Now this time I change it to cotangent squared x minus 1, which is the same thing.
Yeah, that doesn't cancel out.
No.
Okay. I will say that on your test tomorrow, the probability of you having a proof that is this complicated, it's not going to happen. So I won't even tell you probability. I'll just tell you it's not going to happen. But having a proof that is that complicated, like number 54, probable. Okay? This is a little too complex for what I'd expect that to be tomorrow, but this one, that's reasonable. All right, 108 is what we're on now. All right, 108 is 3 sine squared x minus 5 sine x plus 2 equals 0. All right, anybody want to talk about this? What do you think when you first see this? Besides, this is a nightmare. I can't believe I signed up for this class. Oh my gosh.
It's a quadratic.
It's a quadratic. So you could rewrite it as 3x squared minus 5x plus 2 equals 0. You could put that into your quad program.
Does it matter if you're in radians or degrees for this
Yes.
when you do the quad?
Yes.
Switch back and forth.
Well, no, not for quad, but when you do the inverse sine thing eventually.
You do radians or
right now it'll just give you the answer to the zeros that there are. So you should have gotten, what, 0.6666667, which you should recognize as the fraction what? 2/3 and 1. And apparently if you factored it, it would have worked. Anybody factor it? Yeah. But remember, it's not really that x equals that, it's that sine of x equals that. I know sine of x equaling 1 is on my unit circle. Is sine x or y? Y. So if I go to where does sine equal 1, that's at pi over 2 or 90 degrees. Is it asking for radians or degrees right now?